So I'm making this video to help whoever needs some help running through this part, some of these index calculations in section 4 of chapter 2 in that Briggs Bennett and Triola book. I hope this helps. So here's a walkthrough of some of the examples from this section of the textbook. So unlike working with percentages, a percent increase, decrease, or relative change they talk about, we use these index numbers to help us talk about how things now compared to in the past or what they might be in the future. And as you can see from this formula, it's pretty the reference value is very similar to a percent change where we had the old number in the bottom. Same deal here. This is the table that we were provided. Notice that 1975 is the base year, and for 1975, they're regarding that as 100% of the 1975 price. Gas was cheaper back in 65, and notice, so if we to think about that index value, if the 5670 is the reference number, and the 1965 value of 3120, I guess is 31.2 cents, isn't it? We multiply that by 100. That's where they're getting the 55, the index of 55. And the same thing in 1995, gas was $1.20. If we divide that by the 5670, multiply that by 100, that's where they're getting the 210. They more than doubled, and we can kind of see that too. Okay. So we're going to actually do this one example now. So they're telling us the cost of gas today is $3.20. Well, it's not quite that cheap, but we'll go with it since that's the problem. They want us to find the index number based on the 1975 price. So if we take a look at that little table they provided us, we see that the index number for 1975 was 56.7 cents. Since that is in cents, we're going to have to do a little bit with our 320. So our $3.20 becomes 320 cents divided by the 56.7, was it? Yes, 56.7 times 100. And that's one twist that you want to pay attention to, that we've got to convert that dollars and cents into all cents. And we divide those, and what are we going to get here? Let's see. 320 divided by 56.7 times 100. And I got 564.37. We could round that to 564.4. And if you think about it, that's telling me, since this it's kind of like a percentage, this went up. This is telling me that it went up a little bit more than 5 times. And 5 times, I'm doing a little bit of rounding here, but if the 56.7 is about 6 goes into 305 times, and it'll be a little bit more than that. So that's a reasonable amount, and that kind of makes sense. So that's going to be the index price. I guess I would go to one decimal place, depending on, and I forget, this is a math lab question. You'll have to pay attention to the number of decimal places they're looking for. So this is really just a percentage question. If we look at our table, we can see that in 2005, gas cost 407.4% of what it did back in 1975. So what we're really trying to do is find 407.4% of $7. So I mean, the easy you can do this with a proportion. You could say x over 7 equals 407.4 over 100, using that is over of method from high school. Or you could just treat this as change the 407.4% to 4.074, and then multiply that times 7, and that's be what it would cost in 2005. And I'm getting my calculator about $28.52 if I round. Okay, so I spent a lot more than that this morning. So you can certainly follow the method in the book, and I'm actually going to show you a very similar method. I'm just probably going to word it a little differently. They're asking me to find out the cost of gas, the cost in 1955, the cost in 1955. And when I know that the cost in 1995 is $20. So since I have this is what I'm looking for, is the cost in 1955. I have the costs in 95, and they also know some indices here. So I could say that the index in 1995, or I could even say the price, was $120.5 cents, and the cost in 1955 for a gallon of gas was 29 cents, 29.1 cents, and I'm comparing cents to cents. And since I'm working with 1955 amounts over 1995 amounts, I'm just going to stick the 20 here, and then I'm going to cross multiply and then divide to find the answer. Now I don't have to worry about units here, because I'm working, even though I'm working with cents on the left hand side, I'm working with dollars over here. So it'll work out to be the same. The units will cancel out, so I'll be left with dollars. So basically I'm doing the 20 times 29.1 times 120.5, and that will be the amount of money. I'll also show you how to do this with a method the book shows. I just wanted to give this to you as an option. So using the method they use in the book, we know that the index for 1955 was 51.3. We know the index for 1995 is 212.5. We're going to make that a decimal to do that division. And I'm not even going to make it a percentage, because I'm just going to deal with this value, and I'm also all the decimal places I'm going to write. And then this tells me, it's sort of like saying that the ratio of 1995 prices compared to 1955 prices is 0.2414. It's kind of like making it a percentage, or the proportion we call it. So I'm going to multiply that by the $20 that it cost in 1955, and that'll tell me what the cost would have been back in 1955, and I'm getting $4.83 if I round. Okay, makes sense. It's half. It's about a quarter of the cost. Look at that ratio. If I'll just look at the prices, even 29 cents a gallon compared to 120 cents a gallon, it's about a quarter, so that would make sense. Okay, so I don't care which method you use. You could use my one with the proportions, or use this index method. Either is fine. It's the same math, and essentially. Back in the day, when inflation was going up a lot, inflation was high. The consumer price index was in the news all the time. Now I don't hear about it so much. But it's just an index. They set some years the base year, and then they compare to what things cost today to what it would have cost then. And they'll have a market basket. If you take an economics course, you'll find out all about that. And we're just going to look at it straight from the math point of view. So as we can see, looking at this table, that they're telling us that the average from the years 1982 to 1984, they're counting as 100. So yeah, I'm assuming, I didn't double check the arithmetic here, But it kind of looks that way, that if you average those 3 years, you'll get 100, or you can do the between those, and that's got to be close to 100. Okay, so that's going to be our base time. So our reference time, our reference years. So we can treat this as in a similar manner as we did the gas price issue. We know that the ratio of if you look at the consumer price index, we know, let's see, where's my table going to work out the best here? Since we're looking for the cost in 2006, that's 201.6 compared to the 1982 price. So that's the new year. The old year is 172.2. That's the consumer price index for that year. We can just go ahead and suppose they're costing us, they want $30,000 back in the year 2000. What's it going to cost in the year 2006, or what would it have cost? And you can just treat that as a proportion, cross multiply, divide. You can also use the books technique where you're going to divide 201.6 by 172.2, get some decimal, and you're going to multiply that result by 30,000. I hope you see it's the exact same math. When I calculated that on my calculator, I just got 121.95. Of course, I don't think we need to be quite that exact. Again, you'll have to pay attention to what my math lab's asking you to do with that. But that's how you calculate it. Since we're dealing with percentages, that's how we're going to first off tackle this. What's the percent increase or percent change in baseball salaries? So the new figure in 2006 was 2,867,000. We're going to subtract the old 1987 price, or mean salary, and since our 1987 is our reference year, that's what I'm going to divide by, and I'm going to make that a percentage. So the absolute increase was 2,455,000. We'll find the relative increase, the percentage change, by dividing by what the salary was back in 1987. So I'm getting, and I'm going to round to the whole, I'm getting 596% increase. Okay, how does that compare to the inflation that's looking at the consumer price index? So comparing the 2006 index, I'm seeing the CPI was 201.6. Remember, these are percentages. I'm going to divide that by the 1987 index. And then I'm going to want to compare this back. Since I'm comparing percentages, I'm going to change that back to a percentage. So 201.6 divided by 113.6 times 100. I got 177.5%. So inflation, things cost just under 200% more in those almost 20 years that they changed. Baseball salaries, average baseball salaries, went up almost 600%. So, I mean, this is about 3 times the rate of inflation, right? If it's about 3 times the rate, so the average baseball player is doing pretty well compared to the rest of us. So I hope that makes sense. I'm throwing these numbers around pretty easily, but you're always comparing it. Basically, I'm comparing indices, and the same way I'm comparing dollar amounts, but you always have that base year, that reference year that you're comparing to. Okay, so hopefully this will help.